Good morning, students. Today I am going to discuss about Model 3. The Model 3 is the bandwidth utilization and multiplexing and spread spectrum. Then, first of all, what is the bandwidth? The bandwidth is nothing but it is the combination of low and high frequency. This technique we call it as a bandwidth technique or bandwidth. Now, nowadays, the bandwidth is one of the most challenge of electronic communication. Sometimes we need to combine the several low bandwidth or low frequency channels to make use the one big bandwidth or we make use of the one big large frequency. In this bandwidth we are going to contain two methods. The first one is multiplexing method and second one is spread spectrum method. In multiplexing method, our bandwidth, the major role or our major goal of in multiplexing method, we have to combine these several or multiple channels into making in one channel. That is the main goal of our multiplexing method. In spectrum spreading method, bandwidth is it is going to provide the privacy and anti-jumping technique. Then now I am going to explain what is the multiplexing now. Yes, multiplexing it is nothing but it is a technique that allows the simultaneous transmission of multiple signals in the single data link or in the single channel. This technique we call it as a multiplexing technique. In this multiplexing technique, here a bandwidth is very important role because the efficiency of the bandwidth is very important here. Why? Because we supposed to send a huge number of data or huge number of signals in the single data channel or in the single link. We required obviously bandwidth more. Suppose if the bandwidth is very less, during that time I can't able to send the data in the given amount of time. In that time we occur the queuing method. So to overcome these all the problems, we have to use must and should we use the bandwidth here. And then bandwidth is one of the most and precious resource for in data communication. The next one is this is the diagram of multiplexing diagram. In this multiplexing diagram, it contains two techniques, that is multiplexer and demultiplexer. The multiplexer we in short term we call it as a mux and demultiplexer in short term we call it as a demux. Then what is the multiplexer now? The multiplexer is nothing but it contains many number of inputs and only one output, that we call it as a multiplexer. Then demultiplexer is it is the inverse of multiplexer, means it is the many number of output and only one input. This method we call it as a demultiplexer. And every here demultiplexer and multiplexer, it is going to take care or the all the transaction or all the signal transaction, it is going to take care the channels. The only one channel it is going to carry the many number of input data lines to from source to destination. The next one is multiplexing, means different methods of multiplexing. Then now we are going to see what are the methods we are supposed to discuss in bandwidth utilization, this module 3 chapter. The categories of multiplexing is we have three types of multiplexing method. The first one is frequency division multiplexing and wave division multiplexing and time division multiplexing. And then frequency division multiplexing, in this multiplexer it contains the analog signal as the input signal, and wavelength division multiplexing, this is also contains the analog signal as the input signal, and time division multiplexing, the signal if we here we are taken as a digital signal as the input signal. So in the next slide we will discuss what and all each and every different categories, what is the FDM, what is the WDM, what is the TDM. Then this is the frequency division multiplexing. Yes, as of now I told the frequency division multiplexing, the input is they have taken as a analog input. Then the every analog input it contains the many number of channels. Here can you see this the diagram? Okay, the diagram it contains channel 1 and channel 2, channel 3 and so on. See here also in FDM also it contains two method, that is frequency division multiplexing, multiplexing with mux, and frequency division multiplexing with the demux method. Then first of all, what is the frequency division multiplexing? The frequency division multiplexing is an analog technique that can be applied when the bandwidth of a link is greater than the combined bandwidth of the signal to be transmitted. Here the bandwidth we are going to measure in the form of hertz. Actually the bandwidth we are going to measure in two types. The one is in the form of hertz, another one is in the form of bit per second. Whenever we are going to measure the frequency, we have to use the hertz, and whenever we have to measure the speed, we have to use bandwidth as a bit per second. Then what is the FEM signal generated by each sending device modulated the different carrier frequency? Yes, because we never use the FDM method, we never use the frequency as the same frequency here. We have to use the frequency in different frequencies here. In the FDM process diagram, I will show how the frequency will be vary each and every channels. Now, this modulated signals are then the combined into the single composite signal that can be transferred by the single link. Means here, what is the signal or single composite signal? Here, composite signal is nothing but the signal itself have their own shape. That signal we call it as a composite signal. The carrier frequencies are the carrier frequencies are separated by sufficient bandwidth to accommodate the modulated signal. Yes, the sufficient bandwidth is going to accommodate the already whatever we modulate, means at the receiver side what and all we receive the actual signal that should be accommodate the our bandwidth. The channels can be separated by the bandwidth to prevent the signal from overlapping. Yes, we have to overlap here. We have to overcome the overlapping method. We have to prevent, or we have to secure the signals in this FDM method. Then FDM process, yeah, here I told right in FDM process, in previous slide I told in FDM process it contain composite signal and it have the different carrier signals. Yes, here see look at the diagram here. This is the first channel. Okay, the first channel I told in previous slides itself only. Here the input they have taken as a analog input, they have taken as a analog signal. See, this is the channel 1. It has taken the in analog input. Analog input has the channel 1. Here the modulator means the carrier frequency they have taken as a very low frequency here. See, because of that only, can you see the difference here? The carrier signal first diagram and second diagram and third diagram. Okay, this is the very low frequency and this is the medium and this is the high frequency. Here all the three channels they have taken the common input as the analog input, but frequency will be vary. So all the frequency we are going to modulate it modulated with the help of bandwidth. Here, when we are going to modulate the frequency, during that time the bandwidth will be vary, but our phase and amplitude will be same, means it won't change, only the frequency will be vary. The finally the